8051 microcontroller has got a number of timers inside it, and those timers can be also used for counting purposes. So, when it is used as timer, so it is driven by the clock that we have within the microcontroller, and if you are counting some outside event, so you can use it in counter mode, and in that case the events occurring in the outside world will be giving as pulses to the microcontroller, and the microcontroller will count the number of such events. So, we will see that this is very much useful, particularly when you are designing embedded systems. So, it is we need to interact with the environment, and the second important thing is that the delay part that we have seen so far, the delay routines they have got they are soft delays that we have seen, in the sense that we are using some software instructions, initializing some registers to some value, and then decrement, jump node, 0 type of instructions are used to see that to introduce some amount of delay. But as you can understand that you cannot produce any arbitrary delay by those by those instructions, because the instructions have got a fixed number of machine cycles that are needed, and each machine cycle has got a delay. So, when you are using those instructions, so you can get only some of the delay values that are possible. Whereas, if you need a very precise delay, like suppose you are operating a robotic hand. So, this hand has to move in a particular sequence and the delays are fixed, or you are doing say a traffic light controller system, then the lights should be turned on and off for some specific period of time. So, those values may not match exactly with the soft delay values that can be produced using these 8051 instructions. So, in those cases we need to use these precise timers, and this so we will see that these timers the precisions are very high. So, the as far as 8051 is concerned, so it has got two timer counters, the timer counter 0 and timer counter 1. They can be used as either timer to produce some delay, time delay. In that case, the source of the timer is the clock source is the internal crystal frequency. Like whenever we have got a timer module or a counter module. So, this is basically if this is the module. So, it is driven, there are certain things like first thing is that it has to be operated with some clock signal. So, it will be operating on some clock, and there will be some initial value loaded into the timer. So, this initial value will be loaded, and then this when these clock pulses are coming. So, based on these clock pulses, this initial value that we have, so it will go on decrementing, and when it underflows, or so if it is a decrementing timer. So, when the value underflows, that is when the value becomes 0, then when it is trying to reduce from going down from 0 onwards. So, one flag will be generated, which is overflow or underflow flag, which is basically the timeout flag. Now, similarly, you can also have the concept of up counting or up timing, in the sense that you initialize the value with some initial value, and from that point onwards it starts going upwards till some maximum value. So, that maximum value depends on the register that you have here to hold the timer or the counter value. If that value is say 16 bit, so it can go up to 65535, and after that there will be an overflow, and when that overflow occurs, then this flag will be set to say that the timer has overflown. So, essentially you get the time value. So, we will see that very precise time values can be generated by doing this thing. So, we can use this timer as a time delay generator, and the clock source is the internal clock frequency of 8051, or it can be used as a counter. So, in that case, some external input from an input pin will be used, and that will count the number of events that have occurred in that pin from in the outside world. So, and that count value will be kept in the register. Now, this clock pulses that we have, so this may be this may represent many things, like say on a conveyor belt some items are passing. So, you can just you can note how many items has passed, or if you have installed a system at the entry of a room, okay, in the door, like as persons are entering and exiting. So, these values may be updated. So, that way we can have many such examples. Okay. So, number of wheel rotations, any event that can generate some pulse. So, the essential requirement is that whatever event we want to count, so it should ultimately it should be converted into an electrical signal in the form of pulse. So, each event should correspond to a pulse. So, if we can do that, then we can use it for this counting purpose. So, we will first look into the timer operation. So, timer it is set to some initial value of registers. So, set the initial value for the register. So, this TH0 and TL0. So, these are the two registers that are used for this timer 0. So, it is time count high and the time count low, or the time value high and time value low. Start the timer. So, then there is some way by which you can start the timer and 8051 will count up. So, previously we were talking about count down or count up type of timer. So, in 8051, so this is a count up type of timer. So, it will start up counting from the value that we have noted in this TH0 TL0 register pair, and now based on this input from internal system clock. So, it will be updating the value of those registers, and this when these registers will equal to 0. So, that means there is an overflow. Okay. So, depending upon this size of this TH0 TL0 registers, so this register will overflow after some time. So, after going the maximum value, it will come back to 0. So, at that time it will set a bit to denote that there is a timeout. So, this is the generic operation of the timer. On the other hand, when you are looking it as a counter, in that case this 8051. So, this pin number P3.4 and the pin T0. So, this is a multiplexed operation. So, when we discussed about the port 3, we said that bit number 4 is actually multiplexed with T0. So, T0 is an external input, it is basically for timer 0, and this is for the events that are occurring. So, if we have some sort of switch here connected to the T0 such that whenever we close the switch, so it generates the signal value becomes high, and when we open the switch it becomes low. So, basically so in this way we can generate this pulse. A very simple way to generate this switch may be like this. So, we have got some resistor and then we have got say a switch here, and then this point is say grounded, and if we measure the voltage, if we take the voltage at this point, then whenever this switch is closed, you can understand that the value will become 0, and whenever the switch is open, the value will become 1. So, whenever this, so it is just the reverse so of this operation. So, here if we want that whenever it is 1, so in that case whenever it is whenever the switch is closed, the value should be 1. So, what you can do, you can put an inverter and then feed it to the T0 line. So, that way we can do. So, basically we can count the number of times this switch has been closed. Okay. So, it shows the number of events on registers. So, this counter will now this TH0 TL0 pair. So, it will hold the number of events that have occurred, and the value will be stored in the register. For two timers, timer 0 and timer 1, or in that way counter 0 and counter 1, we have got two pins T0 and T1 that correspond to the this external event. So, T0 is for counter 0 and T1 is for counter 1. So, correspondingly they are multiplexed with port 3's bit number 4 and bit number 5. This external input comes in the Tx input pin. So, Tx x equal to 0 or x equal to 1, either of them. So, you can have something like this. So, you are just having this value, and this is available in this register pair, and you can possibly connect one LCD display here. So, that this whatever be the count value, that is available on the LCD. So, that way we can have a system, okay, that can display the number of events that have occurred. Now, what are the registers that are going to use for this timer counter? So, TH0, TL0, TH1 and TL1. So, these are used for holding the timer values or the counter values. So, TH0, TL0 for timer 0 and TH1, TL1 for timer 1. There is one more register T mod, which is timer mode register. So, this will tell this timers, we will see that they can be operated in various different modes, and this T mode is basically holding the mode value. So, we can set these timers to some particular mode before starting it, so that it will operate accordingly. Then there is a TCON register, which is a timer control register. So, this is also useful, and we will see that some part of it is multiplexed with interrupts. So, it will control the timer operation. And 8052 is an advanced version of 8051, and it has got 3 timer counters. So, instead of having 2, timer 0 and timer 1, it has got timer 2 also, and these formats of these control registers will be slightly different, and we have got T2CON. So, for controlling the timer 2 register. So, TH2, TL2. So, T2CON, TH2 and TL2. So, they are for 8052, but normally we will be talking about 8051. So, we will restrict ourselves to 2 timers, timer 1 and timer 0, timer 1, and accordingly we will see the setting of this TMOD register, TCON register and all that. So, basic registers for any timer is like this. So, both timer 0 and timer 1, they are 16-bit wide. So, they are 16-bit timers. So, these registers they store the time delay as a timer. So, like how much time. So, you are initializing it to some value, and from that point onwards, so it will start going up. So, it will overflow when that 16-bit value, that 65535 is crossed. So, in some sense we can say that it holds the time delay that is remaining in the timer, okay. Or if it is counter, then it will hold the number of events as a counter. So, this TH0, TL0. So, timer 0 has got these 2 registers TH0, TL0. Timer this TH0 is the higher order byte, and TL0 is the lower order byte. Similarly, timer 1 has got TH1 and TL1 registers. Out of that, TH1 is the higher byte and TL1 is the lower byte. So, this 16-bit register, it can be accessed as 2 separate registers TH and TL. Okay. So, we will be seeing that while initializing these registers to some value. So, we have to do it in terms of 8-bit registers. So, this is the structure. So, this total I said that it is a 16-bit. So, D0 to D15 for timer 0. Out of that, D0 to D7 is in TL0 and D8 to D15 is in TH0. Though it is written like that, but we have to put the values in separately in TL0, TH0, and similarly we have got timer 1, that is divided into 2 8-bit registers TL1 and TH1. So, these 2 registers are for holding the time value or the count value. Next, we look into the T mod register or the timer mode register. So, this is another 8-bit register. So, in this 8-bit register, 4 bits are dedicated for timer 1, lower 4 bits are dedicated for timer 0. And among that 4 bits, the first most significant bit is the structure is similar for both the nibbles. The structure is similar. The most significant bit is called gate. The next bit is called C by T, that will indicate whether the operation is a counter operation or a timer operation, and then the next 2 bits M0 and M1. So, they will identify the mode of the timer that we want to operate. So, this is one 8-bit register, and it can be used lower 4 bits for timer 0 and upper 4 bits for timer 1. So, if you are not using say lower 4 bits, so you should set these values to all 0, and if you are not using the upper 4 bits, then you should set all these upper 4 bits as 0, but it is not bit addressable. Okay. So, unlike other registers where I can set this set reset these bits individually, here we cannot do that. So, we have to prepare the 8-bit pattern in some accumulator, and then we have to move that pattern to this T mod register, or we can use this type of absolute addressing. So, hash 21 hex. So, hash 21 hex means it will be so 0010 0001. So, for the upper timer, so it is 0010. So, it is gate is 0, count timer CT bit is 0. M1 M0. So, this says that it is 1 0. So, that is mode 2. So, it says that this upper one, the timer 1 will be operated in mode 2, and this is 0 1 means this will be the lower, the timer 0 will be operating in mode 1. So, we will see what are these modes slowly. So, let us proceed. So, next looking into more detail the T mode register. Now, you see that for many of cases, so what we want that these timers, they may be operated on two different situations or two different type of controls, in the sense that maybe I have an application where if some event has occurred externally, then only the timer should be turned on, and when it is running, so it is using internal clock, but as long as some activity is going on in the environment, we should count that. Okay. So, this is one type of situation. Another type of situation is just to produce pure delay. So, I have activated one signal, and maybe it has to be deactivated after some time. So, one type of application is like this. So, I have activated a signal, say signal S1 is activated, and I want that for example, in a traffic light controller system, we want that the red light should be on for say 1 minute. Okay. So, once this red light is turned on, so if S1 corresponds to this red light, so S1 is so red light is turned on at this point. So, we want that for 1 minute this red light should be on. So, this is 1 minute. So, this is not guided by any external phenomena. Okay. So, once the light is turned on, so microcontroller after 1 minute it should turn it off. So, this is one type of situation. So, pure time delay. So, I can say that these are basically I want to produce a precise time delay, and for that purpose I am using it. In other cases, there may be some external event, and for which we want to measure the time that is needed. For example, say we want to make a stopwatch. Okay. So, if we want to make a stopwatch, then I have to start the timer, and then this I have to, when some external event occurs, I have to I press this stopwatch button. Okay. So, in my system, if this is the system, there is a there is a watch button, and when this watch input comes, then only this timer should be activated, and if this watch input is 0, then the timer should not work. So, maybe my watch goes like this. So, watch is on for this much time, then it is off like this. So, my timer should run in this period, okay, and again it should run at this period, and when this watch signal is low in this region, it should not run. Fine. The timer should be stopped in that time. So, so at this point of time it holds the starting from the watch button. So, how much time has passed, or if it is starting at this point, so it can after that again when the watch is activated. So, this value is remembered here. So, this value is carried over to this point, and it will continue like this. So, this way we can have two different type of controls in the operation of timer. In one case, the timer is controlled totally internally by the microcontroller, and in the second case the timer is controlled both by the external event and the internal controller. So, accordingly, so this differentiation is made by this gate. Okay. So, this gate bit, so this tells when whether the timer has to be enabled only while the INTX pin is high. So, you remember that there are two INT pins, INT 0 and INT 1. So, then the INTX, so for timer 1, so if you set this gate bit to 1, then this timer will operate only if this INT 1 pin is high, and there is another control bit TR1. So, we will see this TR1 bit later. So, this TR1 control bit is high. So, normally if you are running the timer without any external interference like say gate. So, in that case the gate bit should be set to 0, and to start the timer we have to set the corresponding TR bit to 1. Okay. So, start timer 1. So, we have to set TR1 to 1. To start timer 0, you have to set TR 0 to 0. So, to run a timer, what we have to do is first set the timer value, okay, and then we have to set this TR bit, okay, the TRX bit. So, that is the operation. So, we will see this location of this TRX bit slightly later. So, we have this gate bit is like that. When cleared, the timer will the timer is enabled whenever the TRX control bit is set. So, if this gate bit is 0, then this whenever TRX is 1, the timer will operate. If the gate is 1, so it is controlled by both the INTX pin and the TRX bit. So, both hardware and software will control the timer if gate is 1. If gate is 0, only software will control the timer. The next bit is C by T, timer or counter select. So, it is select cleared for timer operation. So, if this bit is 0, so we are willing to operate timer 1 in the timer mode, and if this bit is 1, we want to operate the timer in the counter mode. Okay. So, this TX pin should be high, then this C by T pin should be high. And then for as I have already said that for internal operation, when it is operating in the timer mode, so microcontroller's crystal frequency will be taken as the clock, and in case of counter operation, this T0 and T1 pins, so they will be used as input for the event. Okay. So, this T for timer 1 it is T1, for timer 0 it is T0. Then we have got two more bits M1 and M0. So, they are called mode bit. So, depending upon the mode in which you want to operate this timer, so you have to set this M1 and M0 bits. So, this C by T bit, so it is used to decide whether the timer is used as a delay generator or an event counter. So, if it is C by T is 0, so this will be operating as a timer. So, that is a delay generator, and if C by T is 1, then it is a counter. So, this is for counting operation. Gate part. So, gate part, every timer has a mean of starting and stopping. So, gate equal to 0 and gate equal to 1. So, gate equal to 0 means, as I said, that it is totally internal control. So, it is software controlled operation. The start and stop of the timer will be controlled by the software by setting the TR bit. Okay. So, we will see that TR bit. So, you can once you set the TR bit, the timer will start. When you want to stop the timer, we have to clear the TR bit. On the other hand, this gate equal to 1. So, this is external control. So, we have got so it is both by software and external source. So, both software and hardware will control the timer. So, this timer in this case will be enabled when INT pin is high and the TR control bit is set. Okay, that is TR. So, this should be control bit, it is not a pin, it is a bit in the some register. So, this bit should be set and then the timer will start, and whenever to stop it, either you can reset this TR bit or you can disable this INT. Okay. So, either of them can be done for stopping the timer, and in this case to stop the timer you have to disable the TR bit. So, these are the modes of the timer operation. So, we can have 4 different modes of operation with the timers: mode 0, mode 1, mode 2 and mode 3. Mode 0 is a 13 bit timer mode. Okay. So, this 8 bits will be stored in THX register and 5 bits will be in the TLX register. So, x is 0 or 1. So, if you are so for timer 0, x equal to 0. So, 13 bit timer. So, your time value that we have is 13 bit. So, this is the 13 bit value, but but I am using this TH-TL pair for holding the value, fine. So, how to do it? So, this THX will hold the higher order 8 bits and this TLX will have the lower order 5 bits. So, this is that 8 bit, higher order 8 bit, and lower order 5 bits, it will be clubbed with 3 more zeros, that will be holding the lower order lower order 5 bits will be there in the TLX register. On the other hand, mode 1 is a 16 bit timer mode. So, we can get higher delay. So, it is 8 bit THX plus 8 bit TLX. So, total is 16 bit timer value. And there is another very interesting type of timer structure that we have is called 8 bit auto reload. That means, so here so it is after the timer has expired, this timeout bit has been set, the timer will restart. So, it will restart with some initially set count time value, it will be restarting. So, in this case, so 8 bit auto reload timer counter. So, here this THX will hold the value which is to be reloaded into TLX each time it overflows. So, it is the so it is interesting like this. So, we have got this THX and TLX register pair, say TH0 and TL0. Now, this TL0 is actually operating as the timer. So, TH0 just holds the initial value. So, your timer is an 8 bit timer. So, when this timer overflows, then again this TH0 value will be copied into TL0 and it will restart. So, if you are trying to generate a periodic operation, so this is very much useful. So, your periodic delay can be generated in this way. So, you can have this TH0 TL0 pair and this TH0 will be operating like that. Okay. So, this is very useful, and there is another timer mode which is known as split timer mode. So, we will see this when we go into that corresponding mode. It is slightly complex. So, we will go into that.